Hello everybody and welcome back to the Science Behind That podcast. For all of you who are new, the Science Behind That podcast is a show where we take a deep dive into the science of everyday life. Everything from engineering to physics, biology to zoology, and psychology to anatomy, we take a deep dive. On today's episode we will be talking about the science of machine learning and why your Google or Siri assistant is able to learn from your mistakes.
Hello everybody and welcome back to the Science Behind That. As you heard from my lovely AI assistant there, today's episode we will be talking about the marvel of machine learning and what that means for your futures out there, your jobs, and how machine learning works. Originally, I was going to do the episode entirely on how your Google and Siri Assistant works, but I couldn't find any detailed information on that considering it was proprietary. However, it will work in the same way, in a general sense, that machine learning as a whole works. So, without further ado, let's jump right in. Grab yourself your morning cup of coffee and sit down and join me today for Season 1, Episode 5 of The Science Behind That. So, before we dive into machine learning and before we get, too deep into it, let us first establish the different types of machine learning that exists out there. So there are two main ways you can teach an AI or an algorithm to learn. One is called supervised learning, and supervised learning is basically when you teach an algorithm to build a model. So you build a base algorithm or a model, and then using that model, you train the algorithm to make predictions about how a specific set of input data is going to change based on a large data set of given data. And I know that sounds kind of weird, so let me explain another way. Supervised learning is basically, you take, let's say you're building a computer program to predict, a heart attack in a patient, okay? So supervised learning is basically where you take this computer program and you show it hundreds of thousands of examples of EKGs or echocardiograms of a patient who's having a heart attack, okay? And then you tell the program, this is what the heart looks like when it's having a heart attack, right? And then you show it an EKG. You don't tell it whether or not it's of a heart attack. You just show the algorithm an EKG and you say, is this an EKG of a heart attack? And that's supervised learning, because then the algorithm, using what it was already shown, it will make that decision yes or no. And that's basically what supervised learning is. And there are two main techniques to this. One is called classification and two is called regression. And so what a classification technique is basically it's actually basically the example I just gave of a heart attack. You teach the program of what a specific outcome is for a specific input. The input in this case is the echocardiogram of the heart, and the output is it having a heart attack, yes or no? And that is a classification technique because it's a discrete response. And this is, of course, in contrast to a regression technique. which predicts continuous responses as opposed to individual discrete responses for individual scenarios. So what do I mean by this? Well, a regression technique is yearly fluctuations in temperature for a specific environment, right? It's continuous. It's not one example. So you show a computer program or an algorithm, you show an algorithm data of the average yearly temperature swing in Denver, Colorado, we'll say, for the past 8 years, and then you ask it to predict what this year's temperature swing is going to be each month. And that is a regression technique. So to sum up, classification is discrete and regression is continuous. And that's for supervised learning. And so the other type of machine learning is called unsupervised learning. And so what unsupervised learning essentially does is it teaches a computer to find hidden patterns within a set of data, and then draw inferences from that data set without directly labeling the responses. So what does this mean? This means that, for example, let's say you give a computer program a large cluster of data of number of HIV cases in New York, we'll say. And each one of those, or that data is broken down by district within New York. Unsupervised learning would be look for patterns within that data, and then you ask that computer for an output that the program would have to infer from the data. So, is there a correlation between number of HIV cases and temperature, we'll say? And the computer program will look at that data that you gave it, it'll analyze it, and it will infer whether or not that, or it will infer the answer to the question. And that's called unsupervised learning. And clustering is the example I just gave, where you give a computer program a group of data, and using that group of data, it looks for patterns. And so, to sum up, machine learning is broken down into supervised learning and unsupervised learning. Unsupervised learning is primarily taught through clustering, and supervised learning is primarily taught through classification and regression. And so, what does this mean? Well, what this means is that most likely the way your Google or Siri assistant works or learns from you basically is by regression, most likely. Or initially it would have been supervised learning, and then it became unsupervised learning. So initially, when you'd be building a program like that, you would show the AI a large amount of data. In the case of, we'll do speech patterns, and both Siri and Google's voice to text, okay? So what you do is you show the computer program a large bank of data of the sound wave patterns for example, the word the or the letter A. Because each letter in the alphabet is going to have a unique sound wave pattern associated to it. And computers are able to observe those sound wave patterns. And so what you do is you give the computer program a large bank of data of A, B, C, D, E, F, G, blah, blah, blah. And you say, okay, for the letter A, this is what the sound wave looks like. And then you ask the computer program to infer what the sound wave pattern of the word that would look like. And how will it do that? Well, it would combine the sound wave data for all the letters that make up the word that. And then you would show that computer program a large data bank of different words and the fingerprints associated with that. So when you're speaking to your Google or Siri assistant, it's listening to the words you're saying by looking at the sound wave patterns associated with it. And then, because when you first set it up, you train the program to recognize your voice, it can then come up with what word you're trying to say. And that is a mix of supervised and unsupervised learning. So then, the final question that we will touch on is, well, what does this mean for the future of various jobs and of technology? Well, it kind of depends, right? And this is a super heated question, especially in my field, in the field of medicine. It's a hotly debated topic, because at least in medicine, the question gets down to, well, how much can you automate? What things in medicine can you automate by machines, and what things should you not automate? And it gets into an ethics topic, but most likely in the future, it would be really easy for AI programs to come up with quick diagnoses. And if you'd like to see this in action, there's an app on the App Store, and no, I'm not sponsored by it. It's called Ada, A-D-A, I think, A-D-D-A, and it's a virtual health assistant app. And you can ask it questions about your symptoms, and it can come up with a diagnosis, and that's working in the same way that Google Assistant is with voice to speech or voice to text recognition. So that's today's episode. I know this was kind of a weird episode. I did a lot of research on this topic beforehand. Engineering and computer science is not really my area of expertise, but for all of you computer scientists out there or engineers, if I said something incorrect, or if you have suggestions going forward, please let me know at the email thesciencebt@gmail.com. I'd love to hear from you guys. And also, if you think that all my future intros on this podcast should be like the one today, definitely let me know. I kind of like the one I did today. And again, you can email me at thesciencebt@gmail.com. So thank you guys very much for listening to today's podcast, to today's episode. I hope you guys have a lovely Monday morning and a good cup of coffee. And I will see you in the next one. And as always, remember, stand up and question everything.